Hello friends, I am Muhammad Azhar Iqbal Nawalgund, Assistant Professor, Department of Physics, Government First Grade College, Mundargi. Today we are going to study the continuation part of the transient currents. Today we will study the how to measure the high resistance by using leakage method or measurement of high resistance by leakage. When a capacitor of capacitance C and initial charge Q0 is allowed to discharge through a resistance R for a time t, the charge remaining on the capacitor is given by Q is equal to Q0 into e raised to minus t divided by CR. Q0 divided by Q is equal to e raised to t divided by CR, or log Q0 divided by Q to the base E is equal to T divided by CR. Therefore, R is equal to T divided by C into log of Q0 divided by Q to the base E. That is equal to T divided by 2.3026 into C log Q0 divided by Q to the base 10. If R is high, CR will be high, and the rate of discharge of capacitor will be very slow. Thus, if we determine Q0 by Q from experiment, then R can be calculated. For this connections are made as shown in figure. It is the ballistic galvanometer, first a battery, ballistic galvanometer, resistance and capacitance. There are three keys K1, K2 and K3. Connections are made as shown in figure. C is a capacitor of known capacitance. R is the high resistance to be measured. BG, ballistic galvanometer BG is a ballistic galvanometer, E is a cell, and K1, K2, K3 are tab keys, keeping K2 and K3 open. The capacitor is charged by depressing the key K1. K1 is then opened and at once K3 is closed. The capacitor discharged through the ballistic galvanometer, which records a throw theta naught. The throw theta naught is proportional to Q naught. The capacitor is again charged to the maximum value, keeping K2 and K3 open and closing K1. K1 is then opened and K2 is closed for a known time t. Some of the charge leaks through R. K2 is opened and at once K3 is closed. The charge Q remaining on the capacitor then discharges through the galvanometer. The resulting throw theta is noted. Then Q proportional to theta. Now Q naught divided by Q is equal to theta naught divided by theta. Therefore, R is equal to T divided by 2.3026 into C log of theta naught divided by theta to the base 10. A series of values of T and theta are obtained. A graph is plotted between T and log of theta naught divided by theta to the base 10, which is a straight line. Its slope gives the mean value of T divided by log of theta naught by theta to the base 10. As C is known, the value of R can be calculated. R is equal to T divided by 2.303 into C log of theta naught divided by theta to the base 10. Or R is equal to 1 divided by 2.303 into C into slope. Nature of the graph is like this. you have studied in this section that using the equation of time constant decay or discharge of current in RC circuit, an equation can be derived to find the high resistance by using graph. On the basis of this session, we have some objective type questions. Question number 1. Equation to find the high resistance. The options are R is equal to T divided by 2.3026 into C in log of theta naught divided by theta to the base 10. Option B, R is equal to minus T divided by 2.3026 into C log of theta naught by theta to the base 10. Option C, R is equal to T divided by C into log of theta naught divided by theta to the base 10. Option D, R is equal to T divided by 2.3026 into C log of theta naught divided by theta. The correct option is R is equal to T divided by 2.3026 into C log of theta naught by theta to the base 10. Question number 2. High resistance are of the order of. The options are 0.1 mega ohm, 10 milli ohm, 1 kilo ohm, 10 giga ohm. The correct answer is 0.1 mega ohm. Question number 3. Resistance and capacitor are connected in. The options are parallel. Option B, series. Option C, series and parallel. Option D, none of the above. The correct answer is parallel. Question number 4. Nature of graph in measurement of high resistance by leakage method is. The option A, straight line. Option B, parabola. Option C, circular. Option D, none of the above. The correct option is straight line. Question number 5. To measure a very high resistance, we should use option A, leakage method, option B, Wheatstone bridge, option C, Kelvin's double bridge, option D, none of the above. The correct option is leakage method. We have referred for the above session. The books are Electricity and Magnetism by R. Murugesan, S. Chand and Company, 2003 edition, Electricity and Magnetism by D. N. Vasudev, Electricity and Magnetism by D. S. Mathur. Thank you.